All right, I think we are ready to start. So hi, thanks for coming to the talk. So we're going to be talking about real-time analytics. My name's Mark, Twitter handle, etc. down the bottom. So let's start with the definition. So this is the Gartner definition of what exactly is real-time analytics. So they say it's a discipline that applies logic and maths to data to provide insights for making better decisions quickly. So you're like, okay, kind of makes like theoretical sense, but I think it's more interesting to think of this in terms of like an actual example. So we're effectively working with events, right? So an event could be anything. It could be you scanning in to come to this event. It could be you getting a train journey to come here. It could be purchasing a hamburger like on Uber Eats. Anything where something happened. Okay, and we get those events, and there are lots of them, and there are loads of different companies here who sell like platforms that work with events. So I guess that's fairly well known. But we get the events and we're like, okay, well, what can we do with them? So we can do something with the events, but what we actually want to do is can we gain some knowledge or some insight from those events? And then more than that, so like say we get those events of people like buying these hamburgers and we're like, okay, I can get my store and I can stick like a voucher in front of those people. But what we actually want to do is we need to be able to take some action. So it's those three things that make like we're doing something useful. And then the idea is that we're doing that as the data is happening. So we've got events, things that are happening. We're trying to work something out. And then not only do we want to work out something useful, we want to do something as a result of it. So it's either us as a company doing something, or maybe it's users doing something in particular based on that data. And these events come in, and they're on the left-hand side of this diagram. So they'd be like sort of up here. So imagine lots of events are coming in. And then over time, like the value of an individual event starts to lose interest, right? Like as it happens, interesting. So it's like, oh, I know somebody's like coming to this event. Maybe I can like interact with them in some way. But hey, I came to the big data conference and it was last week. So, well, okay, what am I going to do with that information? It's not really that interesting. And so where real-time analytics lives, like for the purpose of real-time analytics, at least, we're interested in the data that's happening on this left-hand side. So either it just happened, or maybe it happened like 20 minutes ago. Like that's the sort of area that we're living. And there certainly is useful stuff that you can do on the data that's coming over to this right-hand side. So we can do historical or batch analysis on this data down here. And we could probably find out something interesting. Like if they were doing the planning for this event for next year, that data is certainly useful from that perspective to see like, oh, where were people actually going? What topics were interesting? But if we're trying to work out stuff that we can do today, we want to be like hovering on this left-hand side. So who's interested in that type of data? So it might be an analyst. So like somebody who's trying to analyze like a business or this event. They're trying to look at like, what are people actually doing? Is there like are people hovering around one particular area of the venue? Can we do something about that? Can we get some seats for these people alongside here, or the people at the back? Like can we react to what's happening like as it's happening? Is there like a part particularly where people like, is there one like particular vendor that people are hovering around? Is there some particular reason for that? Like, so it might be people analyzing the event. It might be a manager like looking at like say Uber Eats, like the manager's looking at the data coming in, people are ordering this stuff. Is there a problem somewhere? Can I see like, oh, there's an issue somewhere with one of the products that I'm selling? Can I try and figure that out? And then equally, we could feed that data all the way back to the user. So like we could feed it back to us. Like, hey, by the way, there's a really good talk going on over there. You might want to go and watch that one. Could we actually feed the data of what's happening in the conference to the people in the conference at the time? Like so that's it. Those are the three sort of people who might be interested in the data as it's happening. And I quite like this quadrant, which sort of shows you like the types of applications that you can build where the data being real-time is interesting. So they kind of fall across these sort of two axes, if you like. So they're internal users and external users. So that's the sort of going along the x-axis. And then it like who's consuming the data? Like who's it going to? Is it a machine who's then going to do something and then show it to the user? Or is it just going straight to the human? So in this top side, we might have observability data. So we're like feeding in like the access logs or maybe the traffic coming into a website, and we're capturing events there. So we want to know like, is there suddenly like a spike of traffic? And we want to be able to automatically, I don't know, spin up some more AWS servers or Azure servers or whatever it is that we're doing. Or is there someone trying to attack it and we want to block like a range of IPs? Like that's sort of observability type stuff. And often data, like tools like Datadog would be sitting up here. If it's internal, maybe we're building some sort of real-time dashboard. So we're taking one of the dashboarding tools, and then we're putting an OLAP database in front of that, and we're building like some sort of dashboard. But rather than, hey, it's the data that happened last week, it's the data that's happening now, or it's the data that just happened. And we want it to be refreshing probably at least every 5 seconds or 10 seconds, maybe even more frequent than that, depending on what we're doing with that data. If we come over to the right-hand side, so external and feeding it to a machine or through a machine, like a machine learning model of some sort, might be like a recommendation engine. So in our food example, hey, I want to recommend you something else. So people who bought that in the last 20 minutes are also buying this thing for some reason. Like if they buy, I don't know, buy hamburger, they're buying they're doing this this topping with it. Maybe we're going to make that recommendation. Or, hey, there's an order that just came in and it seems like this is fraudulent, like something's gone wrong with this. So can we react to that happening in the moment? Like we don't want to detect, oh yeah, there were a bunch of fraudulent transactions yesterday. So, well, okay, now we've got to go back to, now we've got like a problem, right? We've got to go to the bank and say, hey, there was a bunch of fraud here, can you refund it? Whereas if we know, like before they even bought it, cool, like we've done something useful. And then finally, like in our order example, it might be an order tracking service. Like, can I see like my order as it's coming to you? So they do this already, right? Like when Uber Eats are delivering something to your house, or Deliveroo are just delivering something to your house, you can see a little map. Like you can see exactly where the order is. How long is it going to be? So this type of thing. But it could be, there are, I mean, you can imagine there are lots of other examples of like data where we're feeding the data all the way back to the customers, creating some data, and then we feed it back and go, hey, here's a product based on that data. So just to run through some examples, so LinkedIn are a big user of real-time data, so I guess most of you probably use this in some way. So the who viewed your profile page, where it's showing you like, it's almost bringing together real-time data with nearly real-time data. So it's sort of showing you like who viewed it. Like you'll often get like maybe up to the second, up to the like minute information, like who's been viewing my profile. So you're like, who's been stalking me on there? And so you can kind of see, like it shows you all the people. If you have the premium thing, you probably can see even more detail about who the people are. If you're just using the normal LinkedIn, it often hides them. So it's like this person and 4 others. And you're like, oh, I wonder who the 4 others are. So they're kind of capturing like this, like as it's happening, as people are viewing it. And then they're running this at scale. So they've got like 700, 800 million users. And there's lots of people looking at this page. People are also looking at other pages, so they're, for example, looking at the timeline to see, and this timeline is obviously kind of like Twitter's, right? It's not chronological. They're showing you the stuff that they think you're going to interact with. So they're trying to get you to stay on LinkedIn, because indirectly, if you can stay on LinkedIn, they can then sell their products to the recruiters who are, or to other people who are interested in LinkedIn, using LinkedIn to get you to buy something, right? So they want to make this sticky. They want to show you stuff that's going to make you stay on there, and then they want to show you like, very likely, if a friend of yours made a comment on something, like in the last 2 minutes, they want to put that right at the top. So like, hey, Mark, your friend Kareen commented on something, show me that at the top, and then, oh, maybe that's going to be interesting to me. So they want to be able to do that as the post is hot. And that's sort of how like a lot of these, sorry, oh, did I stand on something? Maybe. So they want to be doing this in the moment. Like it's not interesting if they show me, oh, that topic was really interesting like 3 hours ago. They want to show me like it was interesting in the last 2 or 3 minutes. And then finally, like the recruiters themselves have a very like targeted way. Or it often doesn't seem like this, right? Like you get these sort of like jobs sent to you, and you're like, well, why are you sending this to me? But they do actually have very, very fine-grained information on the jobs that are available, like the tags related to them, the sort of skills, like who's employing. Like they should be able to target this like better if they were interested in doing so. And then the Uber Eats, I talked about that sort of before, and this one's quite cool for the, hey, I've got some events and it allows me to take action. Like this is a really obvious example, and it almost allows you to act like a server in a restaurant. So like if you were in an actual physical restaurant, you can see if something's going wrong on one of the tables, and you can maybe do something about it like before the person leaves the restaurant. And so this is like, well, can we like apply that service to the internet? So you can see on here, like we've got the data coming in, so we can see like the revenue numbers coming in. So this is actually a screenshot from a restaurant on Uber Eats. So we can get like the revenue, see like, oh cool, we're making loads of money. But what's interesting in this perspective is we're getting feedback on the menu. So hey, this thing is terrible. Like we need to do something about it. So like, are we making this thing, like have we got like a problematic ingredient that's going into this particular item? Why is everybody hating it? Or if we're up here, we've got the missed orders or inaccurate orders. Like people are going to be really annoyed if their order arrives and it's the wrong thing. But like if we know that it's gone wrong before they get it, can we go and fix it? Like can we stop the order from getting there and do something about it? So like these are the types of data where we can do something about it. So with Uber, it was like, can we do something about the order before the person's really angry with us? With LinkedIn, it's like, can we make this website more sticky? And with Twitter, it would be very, very similar. And then Stripe's another one. So they're sort of running like financial data through this, and like it's allowing them to work out like, are there bugs? Are there some risks that we're able to see by analyzing this data in real time? And so if we want to, so like, let's say we think, okay, this seems kind of interesting. Like, how do we go about building a system like this? So in order to satisfy that, the idea of it being real time and that we can react to stuff as it happens, there are 3 properties. So the first one is we've got to be able to get the data in quickly. So the speed of ingestion needs to be fast. So the data is often coming from some sort of streaming platform, so we need to get it in, like into a place where we can query it, like whatever that is. If it's a stream processor or one of the serving layers or a database, whatever it is, got to get the data in there quickly. Like if it comes onto the streaming platform, we want to be seeing that very quickly in a place that we can query it. When we query it, we want to be able to query this, like often OLAP size data at OLTP speed. So we're looking at millisecond type queries. So we want to be able to like put some indexes on it or do some pre-aggregation or whatever it is, but get it in there quickly. And that needs to be decoupled from the ingestion. So if we're ingesting loads of data, that shouldn't slow down the queries. They need to be completely decoupled in whatever system we come up with. And then finally, it needs to be at scale, right? Like it's either a dashboard with loads of queries running simultaneously, or it's that we're feeding that through to the end users, like in the LinkedIn example. And we might have tens of thousands of people like all viewing who viewed my profile. Like I need to know, like who's viewing it. And lots of people need to know at the same time. So we want to be able to do lots of those queries on whatever data source it is at the same time. So we need to be able to scale it. So get the data in fast, query it fast, do it at scale, like lots of people at the same time. And then, like, I'm going to, like, in the example that we're going to run for the rest of this talk, we're going to be using two tools that are hopefully, like, familiar to you. So we're going to be using Apache Kafka as our streaming platform, and then we're going to be using an OLAP database or column store called Apache Pinot acting as our serving layer. And between them, they're going to be like highly available, scalable, like reasonably cost-effective. Between them, we're going to be able to run like we're not in the demo. We're not going to be running tens of thousands of queries per second because it's only on my laptop. But we could scale that. And then the data we're going to be working with has got high dimensionality. So there are lots of different columns, and we're going to be able to store those and then query and group and filter and aggregate across any of the columns that we want to. So just to do a quick like refresher on the parts of Kafka that we're going to be interested in for this talk. So it's an event streaming platform. Like there's always like potentially an infinite stream of events that we can keep track of. They are done by topics. So a topic would be like what type of data am I keeping together? So it could be the orders are on one topic, maybe the products, the users. If it was page views, maybe they're all on different topics. We can then partition them. So we have a partition which allows us to scale those topics. We can then produce data. So we can produce it into multiple partitions at the same time, and then we can have those consumers taking the data off. There's also an extra thing which Pinot doesn't use, but that you can use if you were building your own platform and potentially other serving layers. So I watched the talk about ClickHouse, and they use the consumer groups, for example, to keep track where exactly have I read up to. So you can keep track, hey, like I've read up to here. Okay, next time I start consuming data, I don't want to go back. I just want to continue from that point. And so Pinot actually like has its own mechanism for keeping track of the offsets, but you could also use consumer groups to do that. Pinot is an OLAP database, so it's column store. So storing like all the data for one column is all next to each other. It allows you to process data from the main streaming platform. So a lot of people are using Kafka, but you can also do stuff with Kinesis or with Pulsar, Red Panda. And then I think on the Startree SaaS platform, they've also added in other ones as well. And interesting, like I'm not going to do it in this talk, but you could actually batch load data as well. So let's say we were collecting a bunch of events like that are happening in real time that we've got in Kafka now, but we batched a bunch of data in S3. We could go and get that S3 data in and load both of them and then query both of them at the same time. But for the purpose of this talk, I'm only going to be doing real-time querying. So just to run you through the architecture, so what does like the serving layer or the OLAP database look like? So we've got a control, on this diagram we've got a controller and we've got the server. So the controller is the manager of the cluster. So it's going to be taking care, like, hey, there's a Kafka streams like ready for us, and we've got 4 partitions. The servers are going to be where the data is stored. So say the data comes in, and the controller is going to indicate like where does it need to go. So stream 1, you're going to go down to server 1, 2, down to 2, 3, and so on. And then that's where those, so the unit of storage in Pinot is a segment. So segment is more or less similar to a partition. So it's a partition of data or segment of data, and then we can set a replication factor. So we can say, in this case 2, we're going to have segment 1 is on server 1 and server 4. Segment segment 3 is on server 1 and server 3 and so on. So if one of them goes down, we can continue to serve the data for that particular chunk of data. So that's the controller managing everything, managing the cluster, storing the metadata in Zookeeper. Servers, they're keeping track of the data. They're storing the data. And then the final bit we have is a broker. And this is who's taking the query from the client. So the client could be a HTTP client, could be a driver like a Python or Java driver. And so they're sending in their query, and the broker goes, hey, I know I'm going to work out which servers need to receive this query. I'm going to get back the data that they send me using a scatter-gather pattern, and then I'm going to send back the aggregated result to the client. And so what I want to do the rest of the talk is I want to show you a demo of how to build like this type of system. If you want to get the code for this, if you want to, probably not enough space to try it like where you're sitting now, but if you want to grab it afterwards, it is here. So I'll let you get a picture of that. And what we're going to build sits in this bottom corner. So we're going to build ourselves a real-time dashboard, just so we can see what does one look like. This is the architecture, what we're going to build. So we're going to get a streaming API. We're going to process it ourselves. We're going to put it into Kafka. So Kafka's our streaming platform. We're then going to get Pinot to listen to the Kafka topic, take the data out, and then we're going to build a Streamlit application down the bottom that is going to be able to show like some visualizations of the data. The data source we're going to use is the Wikimedia recent changes feed. So this is it's a stream like over HTTP, so server-side events, and they give you like all the changes that are being done to Wikipedia like as they happen, and then you can do whatever you want with them. This is what they look like. So you get there's three keys. So we've got an event, we've got an ID, and we've got the data. We are mostly interested in the data. So you can see it's got a schema. It's then got loads of stuff under meta. So it's got a URI, it's got a request ID, it's got an ID, it's got the name of the page. It indicates the size of the page and how that changed. And then it's got any comments that people put. So let's go over to my code. So I'll just open that up. So when we're starting, I'm just going to close this. So it's control. How do we close that? There we go. So if we were wanting to query it, like in a Python script, we can use this SSE client library, combine that with requests, and then we effectively just create a GET request. So that's reasonably simple. We say, hey, I've got stream is true. Pass in some headers that indicate I'm happy to accept a stream. Wrap it in the SSE client down here, and then we get an infinite stream of records. So I'll show you what it looks like. So if we do Python wiki dot. So that's what you get. So you get like these messages coming through. So I think it's about 50 to 100 a second. So it's not massive, but like big enough to show us something interesting. And if I just stop it, I'll try to stop it. We can have a look at what one of the messages looks like. So it's pretty much the same as what I had on the slides. You can see it's got a schema. It says, in this case, it says it's not a bot. We'll get onto the bots as we go through the talk. Near emptiness is the user, and then it tells you which particular part of wiki they've touched. So that's like we can stream that, but what we really want to do is get into Kafka, right? So let's hang on a sec. So if we do wiki to Kafka, so this is our script to get into Kafka. So a lot of it's the same. The extra bit is we create a producer. So we've got a Kafka running localhost 9092. And then through the stream of events, we're going to take each event that they give us, and we're going to put it onto the wiki-events topic. And then every 100, if Kafka hasn't flushed it, we'll tell it, hey, you need to flush this to the disk so that we can get it to run through the whole system. Okay, so that, like, if this works, we will have it in Kafka. So let's get our Kafka cat command. So this is on Ubuntu, it's called Kafka cat. On Mac, it's called kcat. So it's a tool for catting a stream. And so what it basically lets you query a stream, if you like. So if I paste that down here. So what we're saying is, hey, I want to run Kafka cat in consumer mode. I've got my broker running at 9092. My topic is wiki events. Okay, so there's the events coming through. So what we should probably do is let's run our. So those are events that I had from before. So let's run this one. So we'll get that one to run. And maybe we'll do the stream over here so we can see like stuff that's just coming in now. So where's my, there we go. So those are the events that are happening right now on Wikipedia. There are a lot of people. These are not real people, as you may or may not have guessed by now. Like, there's no way people can change stuff this quickly. But that's like people doing stuff. And so we could, like, if we were just interested in just querying like the near future, we could do this with KSQLDB, right? But if we want to keep, let's say we want to keep the data for a bit longer, and maybe we want to do like some optimization so that we can query it, like add some indexes or pre-aggregate around some fields. And so that's where we might want to have like a custom serving layer. And so that's what we're going to do next. So we're going to use Pinot to do this. So Pinot stores data in tables. So we have a bunch of columns. They all have a type. And then you can kind of do SQL querying more or less as similar to what you would do on a relational database. As of the version I'm using here, there are no joins. But as of the latest version, you can join, like do some joining of tables with each other. So we got what we got here. We got our Wikipedia schema. We've got an ID. We got a wiki. We got a user. We got title, comment, stream, and so on. And then we're going to specify a timestamp field as well. And you'll notice that these are all dimensions. You can have metrics, but this data set doesn't have metrics. But if we had any numeric fields, we could put those as metrics. What it means is that if it's a metric, is that Pinot then knows, hey, I can compress these values, and I can then like do optimizations for assuming that you're going to do some sort of aggregation on those fields. So we've got the schema config, and then we have the table. So we call the table wiki events. We indicate it's real time. You could say offline. If you said offline, it expects you to do some sort of batch import of the data. If you say real time, it's expecting to see like a streaming config somewhere. In this, we also specify the schema. And then if you scroll down here, we're saying, hey, it's Kafka. The Kafka broker's running here. Oh, by the way, the reason it's 9093 in here is I've got two different ports. I've got 9093 inside Docker, 9092 for outside, because it kind of gets you to define two different ports. And other interesting things, so it's the wiki events topic. And the other stuff is kind of internal stuff so that it knows how to process it. And then the final thing we have to do, remember everything was under meta. Now, if you had everything on the top level on your data source, it'll just map it automatically and you don't need to do anything. Because in this case, it's slightly annoying, like it's a little bit nested, but I don't want to introduce a stream processor. Like there are really good stream processors we could have used. Like we could use Kafka Streams, we could use Quicks, we could use Airbyte. There are loads of vendors like showing like cool stream processors that you can use. But like for what we're doing, like it's so simple. It's a complete, like we'd be completely underpowering them. Like all we want to do is just, hey, my data is just inside of it. And so what we'll do is we'll use a transformation function to just pull out the appropriate thing. So it's only like a bunch of scalar functions that you can use. So it's not, don't do complicated stuff in here, but if it's just, hey, my field's just in slightly the wrong place, it's fine for that. And the timestamp. Annoyingly, Wiki's timestamps are in epoch seconds. I wanted epoch milliseconds, so I was like, okay, let's change that. Now, if we wanted to create that, so I've actually already created it to save myself time. You could run this command, so you just go add table, here's the schema, here's a table. And then we can go over to here. And we can see what's going on. So this is our table. If I scroll down a little bit, we've got 8,000 things in there at the moment. You can kind of see like there's a bot, or it's not a bot. Can scroll across. You can see the domain, the ID, the stream, the title of the page, URI, and so on. We could probably write a query in here to say, hey, like, show me like it grouped. But it's a little bit too, the resolution's a little bit too low for me to type, so I'm not gonna attempt that. But I will like move on to like showing what we would probably actually do, because it's unlikely that we're going to go, hey user, here's a SQL dashboard, good luck. Like we want to actually put like a more friendly UI in front of it, and so that's where this tool. It's one of my favorite recent tools, although probably not so recent now. So we're going to be using a tool called Streamlit. So in case you've not seen it, it allows you to build data apps in only Python. So you build that, and it will effectively almost builds you like a React-esque like app on in your browser. So they call it a faster way to build and share data apps. You can basically write Python, and it generates the front end for you. So let me show you what the code looks like. So what we're going to do is, you just stream it. So I got a few versions of this, so I'll just can iterate through it. So what we're going to do is we basically go import Streamlit, and then you get like a bunch of functions that you can do. So you can set a table config, you can add a header. I'm then connecting to Pinot on line 9 here, I run a query. So this query here is doing, what it's doing is it's saying, find me all the events that happened in the last 2 minutes, then aggregate aggregate what happened in the last minute, and then aggregate what happened in the minute before, and then do a distinct count of the users who made changes in the last minute, and a distinct count of users who made changes in the minute before, so that I can compare this minute with the previous minute. Like, if you were doing it for real, you probably wouldn't really care about that fine grain, but for a demo like this, it's quite a nice way of doing it. In real life, you probably go, hey, show me today with yesterday at this time. So we do that query, we build a data frame from the results, and then if there's nothing, we write some so you can write Markdown in Streamlit, so you have like quite fine-grained control over what you're putting on the page. But what we want to do is we're going to build some metrics. So, you know, like those big like dashboards, and they go, hey, there's been 100 orders, and it's -7 compared to this time, that type of thing. So we build a metric, we put in a label, a value, and the change, and then we're gonna do a chart underneath it. And so if we come here, if I run Streamlit, run app. So I got _v1. Okay, let's see if that's gonna run. Cool. So this is what's happening on Wikipedia like at the moment. So we've had in the last, well, so you can see like I think I ran it before, like an hour ago, and so this is like since I started it during the talk. So we've got like kind of 2,000 changes people are doing, more or less. 400 users. We could turn that off and say, hey, just show me the users. You can kind of play around this. So this is using Plotly to render it. At the moment, if you did a change in the code, it will automatically refresh this, but it doesn't automatically refresh the whole thing. So it basically runs it from the top to the bottom, and then it stops. But we actually want it to keep on refreshing it. So what we can do, which we'll do in V2, so let me, V2, is we're going to add some automatic refreshing. So what we're doing is we're printing out when did you last update it, and then you can also keep state across the runs. So we're keeping like track of how often do you want it to refresh, and do you want it to refresh, and you can build checkboxes in here as well. So I'll show you that in a minute. And then what we're doing at the bottom of the page is we say, if I'm auto refreshing, I'm going to sleep for some seconds, and then I'm going to run it again. So that's what rerun does. So hey, go to the top, run the whole thing again. So if we come here and we kill this, we'll do V2. So V2 is now auto-refreshing every 2 seconds, so we can make it do every second. So now you can kind of see, like every second, it's going to update how many changes are actually happening, like as we are talking. Like there are just under 2,000 changes being done every second across 67 domains. Like they have a lot of domains, and by 390, almost 400 users. Okay, so that's like a simple thing that we can make. If I show you where we end up, so this is like the finished thing, and again, have a look at the wiki, have a look at it on GitHub to see the final solution. So this is the sort of thing that we can build. So you can kind of build like a sidebar. You can have like, if we just minimize that. So we've got the same chart here, but we can also capture like all the changes as they happen. So you can and it replaces it every second. It's replacing what were the recent events. We can come over here and say, let's just stop the auto refresh. We can drill down and say, hey, who's making the changes? They claim it's mostly not bots. I'm fairly sure that's wrong, right? Like it says 74% of those changes are being done by not bots. We can see what users they are. They're all bots. The top bots are bots. Even the non-bots are bots. Like everyone's a bot. Like there's a lot of bots doing stuff on Wikipedia. So the fuzzy bot, I don't really want to know what this is. There's the MP importer bot. Every time I do this demo, renamer is there, like just changing stuff away. So you can do aggregation at the top level. You can like do it group by columns. You could also do a drill down. So you can say, hey, I want to see those top users. So FuzzyBot is doing mostly changes. Oh, this is a different one, Wikimania. I'm not sure what Wikimania is. I don't know if any of you know. So it's doing changes on Wikimania, mostly doing log and edit. We could change like and say, these are the top users. We can see, that's Qbot, the MP importer bot. it hasn't come up with my favorite edit type yet. There is an edit type called 142, which I have no idea what it is. Every time I look at it, somebody's doing a 142 change. But that's so anyway. That's that's kind of the end of the demo. I've got about 1 minute left. But that's the sort of thing you can build, right? And it's quite like you're just taking these components and gluing them together. So you take Kafka, glue that with Pinot, then it handles like moving the data, and then Streamlit is a really nice tool. But it's not the only one. Like there's tools like Superset. You could use Plotly has a tool called Dash. There's loads of these tools where they're like with very little code and without doing any React. Like I'm not very good at React. It's kind of fun, but I'm terrible at it. Like you don't have to go any front end code. Just do like only Python, and you can build like these things. And so let me just conclude. But I'll share these slides on Twitter afterwards. So like this is the Pinot community. Lots of people are using it. There's a Slack community as well. And so what I've shown you is like we can use these combination. Like there's lots and lots of tools. Like there's lots of event streaming platforms. We've got stream processors. We've got serving layers. We've got front end tools. Like those 4 things or 5 things help us to build these applications that allow us to like discover something. Like if you were actually like using Wiki, you're like, oh, what is going on? Why are all these bots are the main ones changing? Let me like use that to recategorize. Like that we're not doing the bots right, and maybe you could use it to try and work out like which are the actual real users who I want to encourage to do stuff. But whatever system you build, you want fresh data, you want to query it quickly, and you want to be doing it like at scale. Like on this dashboard, we were querying like 10 or 11 different queries to build it. Kafka and Pinot is a pretty good combination. If you want to ask me any questions about it, that's me on Twitter. We've got lots of recipes showing how to build these type of things on dev.startree.ai, and that's the Slack. Otherwise, thanks. Thank you for coming.